You have to mute. We're going to do radical equations, a little bit of quadratic equations, and then rational equations. And then there's a Desmos on solving radical equations, and I'll show you guys that in a minute. Okay, again, none of this applies to you, Faith, because I'm really struggling with, I'm going to say 2/3 of my classes trying to do things their own way because they're not watching these Google videos or coming to. There's Sanaya, I knew she'd be here. Or coming to these live sessions. So I'm trying to get this in there so that people will know that they have to do this. And if they don't do it, I'm going to send them back to this video so they can see it. But I want you guys to photograph your work right side up. If it's sideways, I grade it like this, and that hurts my neck. So I can't rotate it. Once it's in Google Classroom, it's stuck there. So I can't rotate it. I'm not about to download it, flip it. That's just so much work for me. I really prefer people write their solutions to typing. This is what it looks like when you type them. And this takes a lot of effort and it's very hard to read. So I so much prefer this over this. And I know a lot of people think there's only one way to do it, and that's typing, but that's not true. You can write it and upload a photo. I am begging students to meet deadlines. More and more of you are thinking, it's okay, I'll just wait till the last day and submit it all. I'm telling you right now, I'm up till midnight grading this work. And if you wait until the last day and I don't get to you, that's not my fault, that's yours. So if you're not making deadlines, at some point, I'm just not going to take the work. And too many of you think it's okay, she'll make an exception for me, but I won't. So please, guys. Also, I've closed days 1 and 2. So because that was before they forced us to go to the alternative learning plan, all teachers had to. I took whatever anybody did on days 1 and 2, but anybody who didn't do days 1 and 2, you cannot submit it anymore. So please stop trying to go back to the beginning and impress me, because this is closed and I'm not looking at any more work for this. If it's late and I start giving you half credit, then that's on you guys too, because I really, really, really need you to be on topic with this. If there's a real good reason for you being late, I need to hear it. If you're just trying to slip it in late and hope that I feel sorry for you, that's not going to fly, because I'm feeling sorry for me right now. I have way more than I can handle on my plate with everybody waiting until the last minute to get me 4 or 5 weeks worth of stuff. Answer keys with no work are no longer going to be accepted. And if you submit one of these, this is an answer key. It shows absolutely 0 work. It just has stuff circled. That will be your one and only submittal. You will get a 0, and I will not allow you to submit again. So too many of you are thinking, I'll try it, see if I can get away with it. Then when she tells me no, I'll do it again. Nope, not going to happen anymore. And then I've made instructions very clear. I've made videos on this. I've posted notes that clearly state it. And those of you who are not doing any of this and think it's okay to just throw stuff at me without really looking at what I've expected, I have very little patience for you. If you're even aware that there's something due in Google, then you should also be aware that there are other sources you need to be looking at other than the 2 downloads. So please, guys, stop just throwing the answer keys and thinking it's going to be the biggest, the easiest semester I've ever done, because I'm not accepting them and I'm about to start cutting people off with that. And a lot of you say, I did it in Desmos. I don't understand how you think this is showing me work. It doesn't show understanding at all. Also saying I used a calculator does not show me understanding. Anybody can say I did all of the problems in Desmos and voila. I have no idea if you did, if you didn't, but don't tell me you did Desmos, because that's not showing work. And again, copying others, you can't do that. If I think that you've copied, you're going to both get 0s, or all of you, whoever's copying, because I sense that there's a lot of copying going on, because across the board when I look, number 1, your homework is perfect. There's not a single scratch out or erasure mark. So I know nobody does homework perfect. Number 2, it's set up the exact same way as others. And number 3, you use methods to solve that I have never taught you. So if you're trying to use methods to solve something that you've never seen before in class, then that's copying. You know, try and use the methods that I explain as we go through these videos. Those are what I want to see. It tells me that you're actually paying attention. When you take a test or a quiz, you get the points of those that you answer correct. You miss the points of those you don't get correct. It's that simple. We're not doing it on a 0 to 100 basis anymore. And here's your hotline, 850-6875, for any tech issues with your Chromebooks. They are wonderful about that. All right. So that's acceptable work, sideways work, answer key, no credit, typed work, don't do typed. Okay, so Today we're going to solve a radical equation using the IRS, isolate raise to the index solve, and then check it. So remember what isolate means. Isolate means you're going to take the radical portion and keep it alone on the left side and move everything that's outside of the radical to the right side. So this -5 has to come over here. So we added 5 to both sides. That's isolate. Now raise to the index is when you say, okay, this is a square root problem, so my index is 2, so I have to raise both sides to the second power. So I raise this to the second and this to the second. And the whole point is the second power of a square root just cancels each other. So now you just get 3x plus 1, and 5 squared is 25, and when you solve that, you get x is 8. I'm showing you how it can be checked in Desmos, but in no way is this acceptable work. People will do this because they'll think it's okay, it's cool, she showed me how to do it in Desmos, so that's my work. Nope, this is work. This is the check you can do privately, but don't send me any of this. The real check is if you plug that 8 into the original equation, you should get a balanced equation, and you do. Okay, any questions on how you solve a radical equation? Okay, good. This one I'm going to leave in the notes so you can take a look at it and pause the video if you come back to it, but I'm not going to go over it because it's the exact same thing. And this one I will also leave in the notes. So if you notice, the index here is a 3, so we cubed both sides. And when you cube both sides, you will still drop off the cubed root symbol, but then 2 cubed is 8 now, and then I plugged it in. Okay, so here is one that doesn't have a radical bar, but you have an exponent that is a fraction. That's called a rational exponent. Fractions are called rational. So if you have this exponent a over b, a is 3 and b is 2, raise it to the b over a power, because when you do that, 3 over 2 times 2 over 3 is 6 over 6, which is just 1. And anything to the 1 power is just whatever's inside the parentheses that's to the 1 power. So that's going to be just x plus 1. And then 27 to the 2/3 power, you can do this in Desmos, or you can say that's the cubed root of 27, which is 3, squared. 3 squared is 9. Okay, and then when you solve it, you get x is 8, and when you check it, 9 to the 3/2 power does equal 27. So when you see rational exponents, that's fractions, flip that fraction and raise both sides to that flipped power, and then solve it from there. Okay? Now this one is only slightly different. So this time I had to isolate first. I couldn't do the 4/3 power with this 3 hanging outside the parentheses. So when you isolate, you divide both sides by 3. So 48 divided by 3 is 16. Now that I have just the parentheses with this rational exponent, I'm going to raise to the 3/4 power, because 4/3 reciprocal is 3/4. And notice in this one, I have a plus or minus, and the last one I didn't. And the reason is, this bottom number is an odd power, so you only get one answer. It is whatever the cubed root of 27 is positive 3. You can't say it's also negative 3 because the cubed root of 27 is only positive, not negative. But on this one, if I'm taking the 4th root of 16, I could get a positive or a negative 2. And when I cube that, positive or negative 2 ends up being plus or minus 8. Now I'm going to move 4 to the other side. So if I subtract 4 from plus 8, I get 4. If I subtract 4 from negative 8, I get negative 12, and then I divided both sides by 2. So I checked both solutions, and the first one, 2, worked. I put 2 back in the original equation. And the second one, negative 6, also worked. And if you look down here, you can see that it crosses at negative 6 and 2. Once again, do not say I did everything in Desmos. It was so easy. If I don't see this level of work, you don't get credit. Also, I'm not taking resubmittals. At this point on, I need you guys to stick to one submittal only. It's way too much work to grade things over and over. Like I said, if you just do 3 assignments per student twice a week with 114 students, that's 700 assignments I'm checking every week. And then when you guys submit more than once, it doubles. So I can't do it. My wrist is hurting me. I'm actually getting my brace now. So you guys have to get it right the first time. I'm really, really, really having a hard time with these resubmittals. Okay, this is a rational equation with, okay, now we're leaving radicals. These were radicals. Now we're going to rationals. This is a rational equation where you have fractions, and they're equal. So when it's one fraction equals another, you just cross multiply. That means 5 times all of this in parentheses equals 15 times all of this in parentheses. Now, when you divide both sides by 5, because I know 5 goes into 5 and 5 goes into 15, 1 comes here and 3 comes here. And now I can distribute through. So 3 times 2x is 6x, 3 times -2 is -6. This is a quadratic. And this is what I meant when I said you'll do a little bit of quadratics. I put all of these terms to the other side. And just like we solved the last one, you can either use a factor box, you can use, I'll let you use Desmos to get the zeros for this, or you can use a quadratic formula, but the 2 zeros you get if you factor are 5 and 1, okay? And so remember, the check is super important, because if you say the answer is 5 and 1, one of these is extraneous, and I think you know which one. So when I check the 5, no, when I check the 1, I put a 1 in for this x and a 1 in for this x. Well, look, it gives me zeros in both denominators. You can see that both of my denominators have zeros. You cannot say undefined equals undefined, because that's not equivalent. Undefined doesn't equal anything. It doesn't equal itself either. So that means the 1 is extraneous. But when I put the 5 into these two x's, I get 5/8 equals 15/24, which is equivalent. So that one does work. So you had 1 extraneous and 1 correct. Okay, and if the question on a test were tell me what the extraneous answer is, you couldn't go to Desmos, because it only tells you the correct answer. Notice that 1 is not highlighted in Desmos. So you'd actually have to go and find the extraneous answer. You guys follow that? So I doubt they would ever say, tell me only the extraneous solution. They probably want the solution. But once again, you need to work it out. You need to cross multiply if you get one fraction equals another. And this is just one more example of cross multiplying. I'll leave it up so you guys can pause the video if you want to see it. And you only get one solution here because you didn't get a quadratic, so that solution worked. Okay, but if you don't have one fraction equals another fraction, if you have something in addition on the other side, then you cannot cross multiply. That's when you have to do these LCM problems. And these are a lot of work. I know you guys are not fans of the LCM problems, but it does show true understanding of algebra when you can actually work this out step by step. So because this denominator is x minus 1, and this denominator is x minus 1, and there is no real denominator here, I could say that's over 1. My LCM is x minus 1. So I need an x minus 1 for this, but I don't need it here or here because I already have it. So what I did was I said, well, let's take that 2 and just multiply it by x minus 1 over x minus 1. And now look, I have all of the same denominators. When you do, you can say, well, I don't need my denominators anymore because all of them have the LCM. So I'm just going to solve 4 equals 5 plus 2 times the quantity x minus 1. And that's easy. You just distribute the 2, move everything over to one side, and you get x is 1/2 or 0.5. And when I go back and check, sure enough, -8 is -10 plus 2, so that one does work. So I do expect you to do some LCM work, okay? Now, the last one is a little more than just finding the single denominator. I had to factor x squared minus x, and when you factor that, you pull an x out of both terms. That's your GCF. And so you get x times x minus 1. Okay, so let's look. This fraction has an x in the denominator. This fraction has an x minus 1. So I know I need both the x and I need, in parentheses, the x minus 1. Well, this fraction happens to have both of those. So this one can be untouched. We don't have to do anything more to it because it has the LCM. But this fraction is missing the x minus 1. So I did the x minus 1 over the x minus 1. And this fraction is missing the x, so I had to do an x over an x, but this fraction is perfect. So now I can say, okay, look, all of my denominators have the same thing, so I can line through them and just solve 2 times x minus 1 plus 6 times x equals 6. And when I do that, I get x equals 1. Well, I checked it. And when you put a 1 in the first fraction, that's okay, 2 over 1 is fine. But when you put a 1 in the second and third fractions, you get 0 in the denominators. And again, you cannot say undefined equals undefined. All right, so the only solution was extraneous. So there is actually no solution to this LCM problem. All right, so You have 3 things to do: a warm-up and exit ticket and Desmos. I am actually telling you what you need to do in your warm-up and exit ticket. I am not accepting used Desmos. If you submit it saying you use Desmos, you get a 0, and that's the one and only submittal, because people who are not watching videos don't get to take those shortcuts and cause me extra work. So on the first problem, you have to use the LCM. On the second problem, you may cross multiply. On the third problem, this is a radical, you have to do the IRS. You have to isolate, raise to the index, solve. On this problem in the exit ticket, you have to do an LCM. You can see you're going to have to factor x squared minus x. On the second problem in the exit ticket, you have to use the IRS method and check. Don't forget to check, okay? Don't tell me I plugged in 40, I plugged in 5, I plugged in 41, I plugged in 4, and I got the answer, because I'm not accepting that. I'm asking you to show me the methods that I'm bothering to show you as we go through these classes. So the work I'm looking for does not say I use Desmos, and it does not say I plugged in to see which ones worked. So these are the 3 things you owe me. Oh, and the Desmos looks like this. Let me see if I can show you the Desmos. It is solving radical equations. Nope, that's powers of I. Not this one is either. This is powers of I. I don't need it twice. Let me see if I can find solving radical equations. There it is. So it's got the Bart Simpson, and you have to go through and answer some questions. And there's a card sort here at the end. Okay, so please do all 8 steps, but the first 7 are just a single question. All you have to do is drag a point, I think. I'm not sure what you have to do, actually. Let me look. Anyways, that's what it looks like in Desmos. So that's all I have for the day. Do you guys have any questions? No? No? How about you, Samantha? You good, Samantha? Okay. All right. Good luck. Everything is due Sunday night. So today is Thursday. You have Friday, Saturday, and Sunday. You have 3 days to do this. And I will see you guys Tuesday next week. Have a great weekend.